Hello everyone, welcome back. We have again our fourth session on visualization in April. Welcome, I'm Simon, by the way, Simon Walker. I'm Head of Training and Learning at Maxon. I always forget to say that. And we have our range of expert trainers, Darren, Jonas and Ellie with us again. Hello everyone.
Hey there.
Hey.
And the bright and alert ones, I've already said the hello on the questions area. So they're ahead of the game. So hi Jay, Barry and Kent. Hi Barry from Brazil and from Newcastle, Jay as well. And hi Kent, all looking and sounding great. This is good. And I'll give you the usual housekeeping things in a second. Oh, hi Anders and hi Rob. Hi Barry again. I'll give you the housekeeping in a second, but I just thought I'd ask, what are we doing this week? Jonas, what have you got to show us?
Well, today we will have a look at what we can do with cars in Cinema 4D, and to be more specific, we're going to have a look at the new car rig template inside of Cinema 4D S24. I'm going to show you how you can rig a car using that car rig, and we're going to create a simple animation, and then also have a look at how you can tweak car paint shaders. So that's it for today.
It's interesting. We've had a few questions over the last few weeks about this very topic, so it's lovely to be able to talk about it, because some of these are new features in S24, which of course is the brand new release. So if you've got any questions, everyone, about S24 or what things we like in it, please jump in on the questions area and we'll try and cover those in as well. And also, because this is our last session in April, because it's the last Monday in April, fear not, because as you can see here on the events page on the Maxon website, we have more stuff coming. So all through May, we are going to feature fantasy UI graphics, fake, fantasy, futuristic. We'll find out what the F means over time. But essentially, all those kind of screen graphics in the background that you have to spend time to design, Nick, Ellie and Chad and I will be investigating them, and we're very excited next week to have John Lepore of Perception joining us, and he's going to talk more about all the amazing work he's done on all the films. So please come along for that. We're recording this session as usual, so if you go to the Maxon training team on the YouTube channel, then you can see that and see the recordings. This will be up in a couple of hours. And also, if you have a look at here we go, the PDF, which you can see in the handout section of this webinar, then that has all the links for the stuff that we talk about, including various project files. In fact, all the project files for this month. And part one of the links is our thanks to you for joining us live in this session, which is in the form of a free t-shirt. So if you go into the merch store on Maxon and then add that code in, visualization, according to that link, then you can have a shiny new t-shirt courtesy of us. So thank you. Great. Okie dokie. So let me hand over the screen to you, Jonas, so you can show us some of your magic. Thank you, presenter. And hi to Pedro and Glenn and Drake. Hi there. Pedro's already saying this looks fantastic, so you've done a good job so far, Jonas.
Perfect. Let me get this window out of the way here. Well, right. So maybe you have seen it before on social media. I prepared a little clip here of a sports car, and because I think that the frame rate is quite underwhelming when you watch this, I'm gonna scrub through the timeline here, and so you can see the animation. So we've got a car, it's driving around the corner, some drifting, and then it's like driving right next to the camera, and will disappear this way. So that's what I created, and I used the new car rig for that. So here's the scene I was using, and here you can see the car coming, and it's all pretty straightforward. So one thing you can see here is all of the controllers and stuff like that. And if we have a look at the F curves and so on, let me just fold a few of these things. And maybe if I select everything here, you can see we've got 25 keyframes selected. So this whole animation, including the secondary wiggle animation and so on, took 25 keyframes. And if I remember correctly, it was just 16 to get the like drifting and driving and steering animation right. So it's once you set up this rig, you can create animations with ease. So let me jump back to the startup layout. And what I want to do is I want to open up a new scene. I want to open up the asset browser and I'm going to search for car. And now I'm just going to use this one. And if you want to follow along, also later when you watch the recording, just use one of these cars here and then you can follow along. Yeah. So here we go. That's the car rig. And before I show you how to set it up, I want to give you a better understanding of what you can do using this rig, because this will also make things clearer once you set up the rig. So first of all, one thing that I like really much, we've got this master controller here, and if we move it along the Z-axis or Z-axis, and I'm going to do that very slowly, you can see the tires spinning. So that's a cool thing. We can also use this steering controller and steer the wheels. And if we have a look through the window and have a look at the steering wheel here, we can also see that this is also rotating. We have, well, we can reset everything using the reset coordinates button. Then we've got our chassis controller, and here we can create chassis movement, also to the left and to the right, and this way, whatever you prefer. And of course, here we even have controls for the trunk, for the hood and for the trunk. And we could also have that for the doors. That's nothing we added here, but it's there. And then we can go to the funny controls, which are the drifting controls. So here we can add some drift. So that's cool. We can add it here, we can add it there. And now let's have a closer look at the wheels. So here we've got the wheel controls. And for now, I didn't even touch the attributes manager. We can do that in a minute. But once I move the wheel up and down, you can see that the chassis is also moving, and it makes the whole movement like believable. So that's also pretty cool, especially when you want to make this car follow like a terrain, like a landscape object and so on. And I'm going to show you that in a second as well. So another thing we have here, when we select the controller, especially the master controller and the chassis controller, is a few more options. So let's have a look at controller visibility, because what we see here is that we don't see all the controllers. For example, here we've got the car drift controllers. These are the orange ones. And we also have the car tilt vis here. That's this orange one. And the color coding makes sense. Orange means we're moving the whole car. So if I move this drift controller here, you can see that it's the whole car that's moving without the wheels rotating, because that's what the master controller is for. And everything that is green will only move the chassis. This will also make sense in a second. But now I want to show you what you can do with the tilt controller. This is the controller that you can use to create movements like that. Also in this direction here. So this is pretty cool. And if we select the chassis controller, you can see that we also have controller visibility. And here we've got even more. First of all, we can get rid of the steering controller, but we also have a chassis drift and a chassis tilt. So these are actually controllers that help you doing pretty much the same thing that you can do with the main chassis controller, but yeah, like in a different way here, like so, or up here, like so. And another cool thing, let me deactivate the visualization for these two here, and let's go to the controls panel. If I press play and start the playback here, you can see that there is a chassis vibration parameter here on this chassis controller. And if I bring this up, I don't know if you can see it in the broadcast, but now the chassis is wiggling. So this is also something that is really cool. All right, let's see, what else do we have? Let's have another look at the steering controller.
Got a couple of questions for you, Jonas, that have just come in.
Yeah.
If this is a good time. Please ask a couple of ones. What about, can the tire pressure and profiles be affected too? And how about tire smoking, which I quite like? Sorry, whilst you're thinking about that, Sharon's also asked, it's sort of a side question, in R23 and S24 and Redshift, how do you get the materials to not be black in both the material list and viewport? So that's just one for us to process as we go along. But so I just thought I'd throw a couple at you.
Yeah, let's talk about the ones that are related to the car rig. Would you mind repeating them, please?
Sorry, yes. So Clive's two questions: can the tire pressure and profiles be affected, and what do you think about tire smoking? When would you put that in the process?
Well, that's either something you add as a fluid simulation. Well, I'm talking about the smoke, or later in post. If I come back to this animation that I created, you can see that there is a little bit of smoke, like here. But this is like stock footage that I comped in later, and also when the car is passing the camera here, you can see that there is a little bit of smoke on here. But that's just stock footage. If you want to really create like a 3D smoke, you would have to use like a particle system for that. Can be thinking particles, can be X particles, stuff like that. And tire pressure.
The volume for it, or a VBD, as Sharon is suggesting?
Sorry, say it again, please.
Do you use a volume for it, or a VBD, as Sharon is suggesting?
VDB. Well, yes, but I think in combination with X particles would be the best workflow inside of Cinema 4D. Because in the end, you need a volume that you can render. And this is what OpenVDBs are made for. The other thing, tire pressure, is something you would add later. You can add that using an FFD deformer. But let me first explain the whole rig before we jump into side questions, because that's just tracking us to off. All right. Where was I? I wanted to show a little bit more of the controls here. And another good one, especially if you have a look through that window here and you want to make the ratio between the steering wheel rotation and the rotation of the steering here of the front wheels. If you want to align them and get the ratio right, we have the steering multiplier here, and we can set this to 1. And if we do so, you can see that we just have to rotate it just a little bit. So this would really be like the sensitivity of a sports car steering. And if we bring this to, let's say, 8 or something, you can see that it immediately snaps back to almost straight forward, but we can now do a whole rotation. So this is more realistic, actually, at least from what I can say from my car. All right, so let's reset this and let's bring this back to 3. Another thing we have here on the wheel controls is auto roll is on, which means that once we like move the whole car, the tires are moving as well. And we can also roll it manually. And these two are additive, so we can have both. But we can also switch off auto roll and just use the manual roll. And in the controller visibility, we can even switch on another controller, this one here, which is the well controller. And by using this, we can control the well, like so. So this is also a nice one. Now let me show you one of my favorite features here in the master controller, which is well, one of them is path. So we can make the car follow a path, but this is what I want to show you later when we create the animation. I also want to show you the ground collision. So that's a really exciting one. And let's create a landscape for that. Here we go. And we're going to make it a little bit bigger, like so, and so. And now what I want to do is I want to make this the ground for this car. What we need to do first is we need to make it editable. So it doesn't accept the landscape. We have to make it editable so that it's a polygon object. Then it's going to work. And now, again, we go to the car rig, select the master controller, and just drag and drop the landscape into the collision mesh. And you can see that the car immediately snapped onto the surface. And now, if we move it, you can see that it's like magic because it is just doing the right thing. So let's have a look from here. So this is nothing that you need to animate manually anymore. All of the ground collision stuff is handled by the rig, and it works like a charm. So that's a really cool thing and one of my favorite features inside of this rig. Okay,
I love how you were just calmly explaining that. That's so powerful. That saves so much time.
It is incredibly powerful. Not only when you move it along like a street or a landscape, but also like in the shot that I showed you before. Imagine there was one of these ramps where you switch between the levels, where you go to level 1, level 2, and so on. So all of this would be handled automatically. So this is incredibly powerful. Right. So let me show you how you can set up this rig. And in order to show you that, I'm going to bring up the asset browser. I'm going to bring up this car again, and we're just going to get rid of some of this stuff. So first of all, we're going to delete the car rig. Then we're going to the layers manager and unlock the car mesh. And then in here, we're going to delete all of these constraint tags. And there are 2 in here. All right, so now we have like a vanilla car model with textures on it, but you can see nothing is rigged anymore. All right, so how can we add this car rig template to this car? Well, adding it is pretty easy. We just go to character and add the character object, because this is where all of the rigging templates are located. And for the sake of organization, we just make it a child of the SUV small group. All right, here we've got the character object. And here you can see we've got a build tab, an adjust tab, a binding tab, and an animate tab. And this is also the order of steps that you have to take here. So first we build the rig. And we're going to use a template for that, but we don't use the Mixamo control rig, but the car rig. So let's add the car rig. And now we can add the components, and we choose master. So this is the master controller, and then car main. So let's make the car model invisible here. And now you see that this is actually the full rig already. So the only thing that's missing are things like the doors, the trunk, and the hood. Usually you don't need these. If you need them, you can simply add them from here. So you could, for example, add the hood controller. It would be this yellow one, the trunk controller, which would be this yellow one, and the doors. And I'm going to hold down Shift and Command in order to create two of them. If we add more, you can see that we've got the rear doors here. All right, so this is the rig, but I want to undo a few steps like so. So now we've got the car main and the hood, and the next step would be to adjust this rig to the dimensions of our car. And in order to do so, I'm going to make the car model visible again. Here we've got it. And in the character object, I'm going to go to the next tab, which is adjust. So here we go. Now the whole thing is looking completely different. What we have here is a lot of little circles that we need to place in the right position. And as a rule of thumb, first of all, it always makes sense to hover over these circles, because then the name will show up and might give you an idea of where to place it. And the other rule of thumb in here, you should also always rig or place these components from inside to outside. So we start with like the stuff that is more in the middle, and then we go to the outside, which would be the wheels here. So let's start with this one. The pink one is the master controller. And I always like to go to one of the side views to place these things. And the master controller needs to be where the center of rotation of the car is, which is the axis of the rear wheels, but on the floor. Then the next thing, and as you can see here, all of these other circles were moving with it. So that's very important, because if you do it in the wrong order, you might just destroy some things. So the next one is the axis controller here. So this is front axle, and we need front axle for the drifting controls. And we want to place this guy in the middle here, in the center of this wheel. And let me just roughly place it somewhere around here. That's already good. You could also use snapping for that. And we're going to do the same with this orange one, the rear axle tip. And we are also going to place that in the center of the wheel, like so. Okay, now the other ones that were moving along with these two were these here. So this one is the controller, or the anchor point, the pivot of the car tilt. And this should be like at the bottom of the front wheel, like so. And then we have this one here, but actually these are two. So let me show this to you here. It's this one and this one. And these are the tilt controls for the tilt to the left and to the right. So it doesn't really matter where on the Z-axis they are located, but it does matter where they are located on X. So let me go to the front view, and I'm going to place this one here. So at the corner of the wheel, so to speak. So this is the center of rotation when the car tilts to the left or to the right. And this one has to be here on the other side. All right, so this is looking good. So we have the base stuff in place. And now the next thing I want to do, because we can do that here in the side view, is everything that has to do with the chassis. So if we hover, we see that this is the steering wheel, this is the hood, and this is the chassis. So we want to place the chassis first because all of the others here are moving along with it. The trunk and doors would also move along with it. And we want to place the chassis component here in the middle. Then I'm going to place the hood somewhere around here. I think this is the hood. So let's place this one here. And then we need to place the steering wheel things here in the right place. And one thing that is special about this one here, this needs to be in the middle of the steering wheel, in the center of the steering wheel. But the other thing is that this is actually the only adjustment handle that we also need to rotate into place. So we need to align it with the alignment of the steering wheel, like so. Then we can go back to our move tool and we've got everything regarding the chassis in place. All right, what is left? All of the wheels. All right, so if we select this one and move it around, you can see that the other two, if you have a look at the blue ones, are moving along with it. So this is the one we should place first. Then the next one would be the wheel bind, and this one is the one that defines the wheel radius. And the cool thing is, when you move them, you can see that the red side, which is the right side, is moving like in a symmetrical way with what we're doing here on the left side. So you always have to set this up just once, given that your car is symmetrical. All right, so where to place this wheel well bind? Actually, we need to place it at the well, or where the axis of suspension is. And first of all, if we have a look from the bottom of the car, you can see that there is no well. So in this case, we can place it wherever we want, just a little bit more on the inside compared to the wheel. But in this case, it also makes sense to place it in the center of the wheel. So we place it here and we move it to the inside a little bit. And then next we can place this one here, which is the one for the wheel. And we want to place it in the middle of the wheel, like so. And then the last one we have to place is this one here. And this one is defining the radius of the car, of the wheel. And that's why we are going to move it down to this place, to the bottom of the wheel. All right, now let's do the same for the rear wheels. Let's select them. And let's just, do pretty much the same. I'm going to go to the rear wheel here in the side view and just align it with the other one, like so. And put this into place and put the handle for the radius into place. So here we go. Now we adjusted everything. That's it.
A couple of questions, Jonas, just as you've been putting those together about where you've been doing it manually and getting it pretty accurate, zooming in, zooming out. What would the options be for snapping to a particular point? Or rather, of course you can snap, but what would be the process? Would you recommend that? Is it faster to just do it manually?
Well, in this case, I just didn't do it because instances don't support snapping, and some of the wheels are instances. But what you would do is actually, did I select the right one? Here we go. And let's move this one to the side, like so. So it's not in place anymore, but we know that we need to place it here on this cross. You would go to this little button here, which is the snapping menu. And I usually undock it. And then I enable it, because now I could set it up as I want. I could snap to everything that I want, but I just need vertex snap. So I'm just going to move it into place. And here you can see that it snaps. You could also snap it to this one, but this wouldn't be correct. So here we go. That would be the snapping way. And then you disable snapping again, and you can also close this little window. So that would be the snapping approach.
Got it. So that means that you can pretty much adapt this rig to a wide range of different vehicles. Is there a maximum size? Obviously, it would be the same wheelbase and the same setup, but in your experiments?
Well, it doesn't matter. It doesn't matter. As long as it has got 4 wheels, it's all good. It's all good. So the rear wheels can be much bigger than the front wheels, or the other way around. That doesn't matter. It's just, yeah, a matter of setting up the radius here, and then it would react like it's supposed to react to what you want. All right, so now that we finished the adjustment of the components, let's go to the controllers and let's have a look if they are in place. And as we can see here, it looks pretty good, but there are 2 things that I want to adjust. One is I want the master controller a little bit more in the back. But if I simply move it, you can see that everything is moving with it because it's the master controller. So let's undo this. But what you can do in order to make it move like independently from all of the others is you press and hold down 7 on your keyboard, and then you can move it without the other controllers moving. And we could do the same with the chassis controller, hold down 7 and just move it into place. And here you go. Now we set everything up. Maybe this one can be a little bit higher. So yeah, that's pretty much it. Okay, so from here, we have to make a decision. Usually what you would do now, if this was a character, you would go to the binding tab and add all of your geometry in here, and this would automatically create auto weights. But because everything here in the car rig is just static and not meant to deform, we can use a workflow with constraints instead. The advantages of using the constraint workflow is A, that it's a little bit easier to set up. It's B, that it's a little bit faster later in the rig because it doesn't have to calculate all of the weighting stuff per vertex. It's working with all object types. As I mentioned before, some of the car wheels here are instances, so that wouldn't work with weighting, but with constraints. So if we want to make this work with weights, we have to make it editable and make it a polygon object. And the other thing is, but that comes way later in the process, is rendering motion blur. In Redshift, for example, using the constraint workflow would allow you to just enable. Let me go to Redshift. Just enable motion blur here, and then it would work. But if you do this with the weighting approach, you can tick that, but there won't be motion blur because you would have to tick deformation blur as well, because usually everything that has to do with weights and so on is deformation usually. In this case, it wouldn't be, but yeah, technically it's still deformation blur, which would be necessary. All right, cool. So I already made my decision. I don't want to wait this whole thing. I want to use the constraint workflow. And this is why I will skip the binding step and directly go to animate. So what we have here is already the full functioning rig. So if we, for example, move the drift controls, you can see that all of the rig components are moving along with it. And if I rotate the steering wheel controller, you can see, if you have a look at the wheel controller here in the front, you can see that this is already rotating, but there is no connection between the rig and the geometry of this car yet. All right, so in order to make this happen, always make sure that your 3D object is split up and organized in a way that makes sense when it comes to rigging. So for example, the body null here contains all of the stuff that is part of the chassis, all of the interior things, well, everything except for the steering wheel and the wheels. And then we have the steering wheel here as a separate part, and we have all of the wheels as separate parts. And now here comes the step of connecting the two. What I will do is I'm going to select all of the wheels here and the steering wheel and the body. And then I'm going to add a rigging tag, which is the constraint tag. So let's add this. And we're going to set it up for all of these parts in one go. So first of all, we want these to be parent constraints, and parent constraints can or are capable of creating a parent-child relationship between objects, but without putting them into a parent-child relationship here in the hierarchy. So if I set this to parent, I can, for example, make this object a parent of this object, but I don't have to move them in the hierarchy here. The other thing is that now it is important that you have a basic understanding of when an expression is calculated or executed. So the order of calculations here needs to be set the right way. Usually, when you create a rig, you have all of this math stuff going on, and it has to be in the right order. And in the end, this will be transferred onto a bind rig, and the bind rig is the rig that is the connection between the rig and the geometry. And usually, when you know the timing when this when the bind rig gets its stuff, you also know when to put these constraints here. So the parameter that we need is the priority parameter here, and it is set to expression, and then there is a number. And whenever you make this number negative, it will be executed a little bit earlier, and when you make it positive, it will be executed a little bit later. You can go from -499 to +499. I also made a quick tip about what priorities are, and maybe Simon can share this quick tip in the chat, because I even made like a little animated graphic. So what I know here is that my bind rig, and I'm going to the character object display, I'm going to show the full hierarchy in the object manager. Go down here. Here is the bind rig. And if we have a look at the expressions here, like these ones, we can see that the value here is 65. So everything that is bigger than 65 should work. Cool. So let's do this. Let's select all of these and just type in 100. It really doesn't matter which number it is. It just has to be bigger than 65. All right. So here we go. That's the basic setup. Now we need to connect these, because right now it doesn't know where it should be parented to, or what object it should be parented to. So we select one of these, the one for the body, and go to the parent tab. And here we've got an input link field for the parent object. And what we do is we need to input the bind joint for the chassis here. So how can we get this? I'm going to create a new object manager. I'm going to go down to the bind, and I'm going to make this the new root, because this will just set the object manager up in a way that will show the hierarchy only. So here we've got the whole bind hierarchy. And you can see that there is the chassis bind, we've got steering wheel bind, we've got the hood bind, we've got several objects for all of the wheels. And what I need here for the body is the chassis bind. So I will add this one. Then here in the steering wheel, I need the steering wheel bind. So I'm going to add this. And if we move the master controller here, you can now see that it's already kind of working. We didn't constrain the wheels so far, but we can use the chassis controller already. All right. So now let's take care of the wheels, and I want to make sure to put them into an order that makes sense for me. So I've got the front wheels first, front left, front right, right, rear left, rear right, so that I don't get confused. Of course, we can leave them in the other order, but that would be confusing. All right, now here we've got two parts inside of a wheel. One is the one that is spinning, which is front wheel, or which is wheel, and the other one is the brake, this red object here. This one shouldn't spin or rotate along with the wheel. This is like a static one. If it would rotate, it couldn't brake. That would be bad. So let's select the constraint here. And what we need to put inside of this one is the left front wheel roll bind. There is a wheel roll and there's a wheel. Wheel roll is the one that has the rolling components attached to it. So let's add this one here, and let's go to the next one. And here we need the wheel bind. All right. And now let's do this with the other wheels as well. First of all, we need to roll. Then we need bind only. And this is a little bit repetitive, but we only have to do that 4 times. So that's fine. And here we go. If I didn't do a mistake, it should work now. All right, let's have a look. It's working. And on the other side, let's have a look. It's also working. But one thing we forgot is the hood. So we've got the hood bind here, and we've got the hood in here. So let's right-click, go to rigging tags, constraint. Let's make the priority 100. Take parent, and then let's bring in the hood bind, and now it should already work. Here we go. Cool. Now we have a full functioning car, which is rigged. We can use all of these controls and so on. It's just working now. And I don't know, I didn't watch the clock when I started the rigging. I think it's around like 25 to 30 minutes ago, and I explained it. So I can rig this car within 10 minutes. So once you know what everything means and which buttons you have to press, it's dramatically straightforward. Let's put it that way. So let's create a little animation.
5 minutes, Jonas. Even if it took you this long to do it, you're still saving hours from all the other setups and so
absolutely. I mean, like in the last year of my freelance time, I had to rig, I think 3 cars, and rigging each one of them took me at least half a day to 6 hours, something like that. And now it's pre-rigged. Brad Bass, who created this car rig template, is a rigger for Disney, so he knows what he does, and yeah, he made all of the work for us. We just need to know how to assign it to a car that we created or that we received from a customer or whatever. But the rigging process itself is really straightforward. So now let's animate this whole thing.
Jump in? I'm sorry, Jonas. I feel really bad to interrupting, but it's just a couple of things that would be really great to mention at this moment. We've had a special guest lurker in the background. Good old Thanasis, or AKA Noseman, has been watching what we've been doing, and of course, he's jumped in and he's built a tire pressure deformer and a collision rig. So, these are two project files which you can download from the usual demystifying location, which I've just posted in the chat. You can find that in the PDF link, or the link is in the PDF that we have in the handout section. But I think he has access to the microphone. If you've got any questions for him about those, please jump in. But I just thought I'd interrupt you and mention, because of course, what else does Noseman have to do except see something, recognize a need, and then build it? So this is why we love you.
Immediately.
Immediately.
Yeah. So yeah, it isn't too straightforward to add this deformation stuff. But it's also really cool that Thanasis built it. So what you would need to do is you would create like an FFD deformer and make it a child of the wheel joint, or make it a child of the tire, of course, but also make the wheel bind apparent using a constraint. So this way you would make sure that the FFD is always a child of the wheel also when it's steering and so on. But then you can just create a deformation using the FFD that puts the wheel here on the bottom part up a little bit and pushes it outside, so that you have this the impression of pressure, so to speak. So if you want to add that, you can also try it yourself, but it's always cool if you have someone building it for you. So thank you very much, Thanasis, for this one. That's really cool and helpful for everyone. Let's just create a little animation, because one thing I teased before is that this car can follow a spline, but I didn't show it because I wanted to show it now. So here we go. I want to create a spline, and I'm going to do this like so. Just create a little bit of a inverted U shape, like so, and just put this one here. So now we've got our spline, and we want the car to follow the spline. First of all, what I always do when I want something to follow a spline is I set the intermediate points to uniform and crank up the number a little bit to have it as smooth as possible. But what we do now is we select the master controller. Well, let me tidy up this a little bit. So in the character object, you can always go to display, and here in managers, object manager, set this from full hierarchy to controllers. This way you only have the controllers. So we go to the master controller, go to controls, and here we can input the spline path. So let's just drag and drop this in here, and we can see that our car immediately snapped to the starting point. And then I'm going to set a keyframe here, and I'm going to extend the range here to 120 frames, and I go all the way to frame 120 and bring this to almost 100%. Because what happens when I bring this to 100% is that the object that is, well, right now it's even working, but usually what happens is that if you bring it all the way up to 100%, it will look into another direction, but only at 100%, because there's something going on with the alignment controller here on the spline. So usually what I do is I set it to 99.9, which is almost 100%, and this would be the workaround for the car doing like random rotation here on the 100% position. Okay, so what we have now is the car driving from here to there. So that is already pretty cool, but let me show you something else. Let's have a look at this car from this perspective, and let's create a camera, and let's make the camera a child of the master controller, and let's have a look through that camera. And as I scrub through the timeline, when we come to the place where the bending happens, or where we go around the corner, you can see that even the steering is automated. So this is a real game changer. It makes animating cars so much easier, because usually you make them follow a spline. At least that's my experience from production. So this is really cool. All right, now let's get rid of the camera. We don't need it anymore, and let's add a little bit of drift here. So what I would do, first of all, let me jump to the animate layout, and let's have a look at the F curves of this one here. So here are my F curves, and I'm just going to make it a little bit invert here. So we're starting with full speed, then we're slowing down here in the curvy area, like so, and we're going to full speed then. Of course, we could tweak that, but that's not necessary for now. What I want to do here is I want to make the drift start. So what I do is I select this controller here, and I set a keyframe at the X value. And then I go here and just move it to the side, like so. And I set another keyframe for X. Then I go to something like this, set another keyframe, and here we should go back to the initial position. So this is what we get. It's drifting here and doing something like that. Maybe we can extend this a little bit. So yeah, the retiming is something I won't do now, but one thing that that is challenging right now is usually right here you steer against your drift, but because we have auto steering on, that's not possible. So what I do is I deactivate auto steering, and let's scroll down here. Here we go. Auto steering is set to 100%. I can bring this down to 0, and now I'm in charge of the steering. So what I do is I zoom out a little bit, then I go to this position, and I'm going to keyframe the steering wheel controller. Here we go. Did I select it? Yeah. All right, so let's go to the coordinates. This is the banking, so we have to set a keyframe here for the rotation B, and let's set the right amount, something like this, and set another keyframe. That's looking good. And then here, well, around here, we need another keyframe and rotate the steering wheel so that it's going to the other side, like so. Set a keyframe. And around here, where we are straight again, we set it back to 0 and set another keyframe. So this is already quite cool. And the last thing we need here is a simple is a simple rotation here on the chassis. So what I do is I'm going to keyframe all of the angles, and then I'm going to rotate it like this, and I'm also going to rotate it like that. Maybe that's a little bit too much. We need to make sure that we don't intersect between the body and the wheel here. But yeah, that's good, I think. And then we set another keyframe here. And if we go to this frame, this one here, we can just bring it back to 0 and set another set of keyframes. Right, so for now, that's okay, I think. One thing that is really helpful, especially when you want to control what you're doing, is you can go to Filter and Geometry Only Playback, because this allows you to select all of the controller objects whenever you don't play the animation. And as soon as you play back the animation or scrub through the timeline, you can see that all of these controllers and all of these unnecessary elements disappear, and you can 100% focus on the animation that you're doing. And
this is a new feature of S24, Jonas.
That's a new feature, yeah. So geometry only playback is a new feature of S24. We added geometry only one release earlier, but then it was clear pretty soon that we needed geometry only playback, so we added it. All right. Yeah, that's the whole rigging and animation part. So what you can see here, although the animation could be improved, but it took me like 45 minutes to rig and animate this car. And maybe let's have a look at all of the keyframes and let's count them. So right now we have 23 keyframes. That's not too much for an animation like that. All right.
Really, we got a handful of questions that the team have been diligently answering in the background, but they are quite some of them are quite interesting in terms of the options to reconfigure what you've set up and so on. And just coming back earlier on, there were two really interesting ones. One was right at the beginning when you were showing how it automatically follows the terrain, and was linked with how, if the scale of the terrain changes, will the car automatically change consequently, or do you have to watch out for the scale differences?
No, let me go back to, which one was it? This one? Yeah. So as you can see here, when I move the terrain, the car is also reacting. And the same thing happens when I scale it up or down. So this is 100% flexible.
Excellent. We had a couple also of questions about swapping out the car and how you can do that more quickly. And so the general consensus seems to be you can adapt the rig to the car, but it's still a quicker process. And as a kind of side question to that, we had a couple of questions about how you might take this rig and then take it to an external application, maybe even something like Unreal.
Well, that I don't know, to be honest. Well, exporting rigs and importing rigs into other applications is always a little bit tricky. So I don't have an answer for that. I would think without further investigation and maybe adding a few lines of script, I would say it's not possible. When it comes to Unreal, I'm not sure. It might work, but then you have to add all of the expression and programming stuff in Unreal. So there is some amount of work involved whenever you want to take a rig and put it into another application, that's for sure.
But this is a faster way of doing it for sure.
Yeah.
or setting up the original rig. Yeah, absolutely. And it's those subtle details that you were just showing us, like the steering actually pointing in the right direction when you're drifting. I was just imagining you out last weekend testing this out with your car just to make sure you were doing it accurately.
Yeah, and also what I really like is the wiggle control on the chassis controller. So the chassis vibration, that's a really awesome one. When you hit play, that the car is automatically wiggling here. That's cool. That's just adding to the animation. You know?
There's Michael's just talking about the exporting, is talking about Alembic as a method. I'm guessing it's Darren who's just jumped in that says Alembic will work, but not on all the actual features.
Well, the point is when you want to bake the geometry out, it will work. But keeping the rig intact is the challenge, and I think it's not possible.
I mean, you could. I mean, if there are joints in here, you could do like what, FBX or whatever the current standard is for moving joints around. But you don't get all those controls. This rig was built for Cinema 4D.
That's a good one, Darren. Because here in FBX, given that you didn't use my approach here, but the other one that I mentioned, like weighting everything, you could export the bound joints only, and this way you could export the geometry including the bound joints, but you won't have more control than that. So the animation in the joints would be baked, but it should export the rig structure correctly.
Yeah,
I didn't try it, but it should do.
Edward's got a follow-up question to the one that was earlier on asked about using deformers to set up a dynamic car crash. And is that something, Noseman, that you considered when you created your instant deformer rig? And just in case you missed it, Thanasis has been watching in the background and has uploaded to the download section where some project files where you can set exactly this up.
Well, the one I've posted called Collision C4D shows sort of a very general principle on how to do that. I can share my screen. I've got it in front of me right now. If that's something that can be easily done.
Well, that would certainly be great. Sure. The regular viewers will know that we have a tradition of slightly overrunning, but we've mentioned this before, and you've been very kind and forgiving and say yes, show us stuff. So I think in that vein, we'd be delighted to do it. So I can chuck it over. Was there anything else that you wanted to mention before I do that, Jonas?
Well, we could have a 5 minutes chat about car paint shaders, but we can also, because it's related to rigging, it's better when Thanasis shows his scene first.
Okay. All right. So forgive us, everyone. We'll overrun by another 5 or 10 minutes. Well, we'll try not to be too long. You know us. We love this stuff, so we can't stop talking about it. Right. I'm going to make you presenter, Thanasis.
Show my screen. Good. Does everyone see my screen? Very simple setup with the cube and the sphere. So the concept is the following. Mind you, if you're doing a car or anything more complex, it's not going to be as easy as this, but the main method stands. So there are no dynamics here or anything like that. What I've done is I've created a sphere as the collider object, and I've hand animated my cube, right? There's nothing dynamic here. It's just a bunch of really bad keyframes. If you go to the F-curves, you will see that I've just created this, which is some rotation, some motion, and so forth. Now, once you've done that, in order for the, let's say, deformation from the collision to happen, what I've done, I've used the cube, and under the cube, I put a collision deformer. Now, in the collision deformer, you need to set the collider, whatever objects are going to collide. It could be one, it could be more than one. Am I getting feedback? Is it better now?
Yeah, no, you're fine. I was doing that just to see if it would pop up on screen.
Okay, okay. Sorry. So the collision deformer allows an object to collide in certain ways. It's not dynamic collision, it's just a deformer that pushes the points based on their normal direction. Okay, now the trick to do this, because by default, the restore shape, if you go to reset to default, the restore shape is 100%, which means once this collides, upon retraction, it will go back to its original shape, right? This is to create objects that sort of squeeze when they come close to another object. But if you set the restore shape to 0, then this will not happen. So once it crashes, it will retain that shape. And of course, you can play with this using the curve or add a bit of, return to the shape so you can see sort of unfolding, and you can play around with this. Now I set it to 0, so I have my initial sort of collision, but then I want to add some secondary animation, and for that, always use the Jiggle deformer. If not for anything else, because it's fun. And the Jiggle deformer now is going to allow for a small amount of secondary animation. And I've added a spherical field, which is sort of encapsulating the sphere. So only thing within that sphere, you can see we get that secondary jiggle. Only within the bounds of the sphere, though, okay? So none of the rest of the cube is doing that. Otherwise, I think the whole geometry is going to move. Yeah, the whole thing, you can see now it's sort of jiggling up and down. Whereas if I confine it to the front, I get this secondary animation. And one little tip before I end this, when you are in the object mode, the Jiggle deformer, make sure you turn off the structural, which is by default higher, because under certain circumstances, it's going to create some serious deformations on, secondary and ripples on your object. Because now I have the spherical field, it's not very obvious, but make sure if you're doing these things, just set it to 0. And this will be a, let's say, prototype baseline method by which you will use on different parts of the car. But there is no automatic collision creation and metal scrapping deformer and so forth. But by strategically placing your collision deformers and your jiggle deformers, if you require that to get the secondary jiggling, you can actually create structures, cars and all that, that will deform, especially the large surfaces. For things like the wheel breaking and falling off, that's something you'll have to do manually. And that's all I have.
I want to add something to that.
Yes, please, please.
I want to add something to that because the Jiggle deformer comes with another huge advantage. Even if you don't want to make something jiggle, the Jiggle deformer is the only deformer that allows you to cache the stack of deformers. So what you can do with the Jiggle deformer is, although even if you have other deformers in there, you can just place it there. Don't make anything jiggle, but you can cache all of the deformations that you created before using other deformers. I'm not sure if that makes much sense here. In this case, it even makes sense because it's jiggling, and in order to make it render on a render farm, you need to cache it. But other than that, you can cache everything that you created using deformers, and then you can even delete all of the other deformers. And just leave the cache on. So that's something you could
exactly.
do for like motion graphics setups as well. Whenever you use deformers, that's one of the huge advantages of the Jiggle deformer, and one of my there are actually just 2 use cases for me for the Jiggle deformer. One is making stuff jiggle, and the other is caching stuff.
And it even has gravity and all that, and accepts the forces to apply on the surface of the object. And adding to Jonas, the reason why you would do that is that because this is a procedural object or a generated object, you cannot go and use the point caching techniques. I think it's in the rigging. The point cache does not work with generated objects. So in this particular case, the jiggle caching is an exceptional way to go. Good. How do I return the screen to someone? Are you going to steal it from me, or shall I?
I can try stealing it from you.
You can try doing that. I just pressed the button.
I think I already did it.
Good.
Can you see my screen? Can you see the car again?
Yep.
Yep.
Yes, we got it.
Perfect.
Are you going to get into the car paint shader?
Yes.
Okay, let me just say real quick that I uploaded a file with just a simple classic PBR 3-layer car paint shader, and Simon is going to be including that. So FYI.
That's already uploaded into that Dropbox folder. So if you see that link in the chat where it says there's a bit.ly link, it's visualization project files. In there are all the project files we talked about today and also for the last few weeks.
Yeah, so what we have here is, well, just a simple object like a torus or two toruses with a car paint material on it. And you can see that the car paint material is a little bit special because it has got these flakes, and I want to show you how it's built. I want to show you how you can create car paint shaders for physical renderer and as well as for Redshift. But one thing that I want to show you, especially here in Redshift, is how to create these little scratches on top, because they add to the realism. Especially, I don't know how it comes through the compression, but you can see that
I can see
the
it.
specula is broken up here, and this adds a lot of realism. So, yeah, let me just get rid of the rendering here. Let's stop the IPR, and let's also, first of all, show you how you can create a car paint shader using physical renderer. So what you would do is you go to create and node material presets, and it is as easy as that. You just add car paint. So here you go. That's the car paint shader that has been created using the node-based materials inside of Cinema 4D. Rendering it now would take a little bit too long, but as you can see, we can adjust the color here. We can make it blue or green or whatever color we want. We have some settings for the roughness and color shift. And here we've got a flake section that allows you to bring up or lower the intensity of the strength strength of flakes, the density, and the scale of flakes. And then the gloss is the clear coat layer, which is on top of that. And there you go. That's the easiest way to create a car paint shader for standard renderer as well as physical. If you want to do it yourself, and I think that's pretty much what Darren did.
Yeah, mine is the classic reflectance layers.
Okay. Yeah. Yeah, I'm going to show that here as well. So you just create a normal material and just get rid of all of the layers. So what we have here is, well, in the most basic scenario, it's just one layer of like metallic reflection with a clear coat on top. Of course, you can add flakes. That's what Darren did in his setup, right? Is it?
Do you want me to? I can show the breakdown. I have it open if you like.
Yeah. Okay. Are you going to grab the screen, or do you want me to?
You want to toss it over?
To throw it at you?
Ouch!
It's an interactive session today. This is great.
Okay, show.
So here you go, Darren.
Screen. All right, you can see my screen?
Yes.
Yes.
Okay. So here's the final render with all the layers. I'm going to zoom in on this area. So we have the base layer. Here is just the flakes. Here is the clear coat, and then finally all three of them. So let me actually show you that material. Now this material I've saved as a separate file, and Simon has included it. So the base layer is a GGX with a pretty high roughness and a color for that base color. The flakes, I've added a color there in the layer color, and to get the actual like flakes, I got a noise in this layer's layer mask. And it's very small, and I've really crunched the black and white values. But to get the different angles of the flakes, I have a custom normal map, and I'm doing a very awkward trick here. I'm using a brick shader set into displacement mode, so that there's all these little gradients on every brick. And I just sort of crossed my fingers that it would work, and it actually did contribute and made it look like added some variation to the angles, or at least appears to do so to me. So that's the flakes, and then the clear coat is just a basic Beckman dielectric glass for now reflection. And yeah, so that material is uploaded, and I can toss this back to Jonas.
Cool. It's really looking great. I really like these areas where the speculas are showing up. Really cool.
Just in the background, there's a whole team of us supplying ideas for this. Dr. Zassi has created a point cache for a primitive, which can be done with the correction deformer, but it might be, in terms of what Noseman thinks, it might be slightly controversial. I think you consider this cheating, don't you, Noseman?
In the end, it has to look right. It doesn't have to be right.
If it works,
I say, yeah, that's a joke, as if anything is real. It's all cheating, by the way. Don't forget, everything is cheating, right? There's no physical-based anything, right? Just remember that.
Okay, so let me. Well, I could have done that in the meantime, but I'm going to switch back to my Redshift rendering here, and I'm going to create a new Redshift material car paint. So here we go, and I'm going to assign it to the 2 here, and just hit render, start the IPR. All right, so what we have here is the basic car paint, or the basic car paint shader, and we can break it down a little bit because it does make sense. So first of all, let me get rid of the clear coat. Let me get rid of the metallic flakes by bringing down the weight to 0, and also of the base layer specular. So what we have here is just the simple color, but it's not as simple as that. We are just seeing the base layer diffuse. But what you see here is that we actually got 2 colors. We've got the pigment color, and we've got the edge fall of color, which is like Fresnel based. And if we adjust the colorization here, you can actually see what's going on. We've got red here, we've got green here, or here on the edges, and then there is this curve factor. And by adjusting the curve factor, you can see that we can like adjust the Fresnel that is used to mask the 2. So usually I would keep the 2 colors close to each other. Well, at least nothing more than that. But this is also something which is a matter of taste. And then the base layer specular would be like a rough reflection on top of that. But before we add that, let me bring in the metallic flakes first. So I'm going to crank up the weight here. And what you can see is pretty much nothing. So what I'm going to do is I'm going to bring up the glossiness. And now we can start seeing the flakes here. We have several parameters to adjust the flakes. For example, we can adjust the density, we can adjust the variation, we can adjust the scale. So let me bring this up a little bit, maybe even like so. And now you can see it even more clear. Now we have more flakes. We can bring up the density, let's say to 0.6, something like that. We can also, but that wouldn't be physically correct, bring up the weight to something like 5, just to see better what happens, or to increase the radius here to increase the effect. But it's not physically accurate anymore. So a weight of 1 would be the maximum. However, we're faking here, so if it's looking better, just overshoot. And yeah, then let's add back this layer here of rough reflection. I think it was 0.3, and add the clear code on top. Yeah, something like that. So one thing that is missing though are the scratches, because usually what you always have on car paint are these micro scratches, and these micro scratches are like, yeah, just adding something to the speculars that you always have like a little, yeah, corona of streaks around the speculars, and I want to add this here as well. So let's try to find a way how to add these scratches. So the first thing I would do is I will go to the asset browser. I'm going to search for scratch, and here we've got some scratch maps. Well, I also marked some as favorites. So let me use this one here and just drag and drop it into the shader graph. And I'm going to have a look at this one. So this is what it looks like. By default, it's using the UVs, but I want to yeah, make it so that it's using a triplanar. So I'm going to add a triplanar node. Here we go. And I'm going to input this texture into image X, and in the triplanar, well, let's solve this. You can then see that the texture will be projected from each side of the cube, so from X, Y, and Z directions. And the cool thing about triplanar is that it's not just like cubic mapping, but what you have here is a blend amount slider. So maybe let me show this on the other torus here, because I added some geometry to the other one. So what you can do here is you can bring this down to a blend amount of 0, and then you see this sharp edge here. But if I bring the blend amount up, you can see that there is a transition, a fall off between the two. And now you cannot see that these are actually two different maps. Well, I'm having a few artifacts here. Let me just restart the nodes. Something is wrong with my system at the moment. I'm getting a few glitches here. However, what we can do now is we can, first of all, make the texture smaller. So in the file, in the texture node here, I'm going to general, and I'm just going to increase the scale value, which is actually the timing. And let's have a quick look. Here we go. So now we've got smaller scratches, which is perfect. And now I'm going to pipe this into a bump node. So let's add a bump map node. And I'm just going to use this as the texture input, and I'm going to use the output here in advanced bump. So it's not an overall bump because we're using the car paint shader here. It's an advanced bump. So here we go. And now we can make this, or we can connect this back to the output. And now you see that this is pretty extreme. Of course, scratches aren't that deep. So let me bring this down to something like 0.03. And let's also search for the area where we have the specular going on, because this is where you see it best. Here we go. And let's have a look at this. So yeah, this is a little bit too much. So let me bring this down. Yeah, you have to be really careful here with the height scale. You have to make it, sometimes you have to make it lower than you might expect, because once the texture is so small, you really need a very low height scale in order to get these little scratches here. Here you can see that.
That looks great.
Maybe we can even go lower, like so, because what I would like to have is a little bit more specular here inside of the specular. It's getting even better the more I lower it. So here we go. Now here we have the specular and we have some scratches around it. Oh, maybe this was better. But you get the point. You need a little bit of micro scratches to make it look more natural. You need this small detail to sell a shot, and it's always about like the small details. So whenever you use something out of the box, you might need to add like a little bit more time to add the extra detail to completely sell the shot. You know?
It's that small detail that makes me sad every time I look at my car. Scratches on my car paint.
They also inside of the car. It's like using the scatter pen with leaves and dirt and
crisp wrappers and so on. Yes, exactly.
Yeah, maybe you noticed it yourself. At some point, even in real life situations, you think like the equivalent in 3D, or like if you look at the plan, for example, you're thinking about subsurface scattering and not about like how the leaf is looking. That's what I
mean. You see artifacts in the sky, don't you, Jonas?
Absolutely, absolutely, always.
Excellent. Cool. I'm going to grab the screen, if I may.
Absolutely.
Thanks for all the kind comments, everyone, by the way. People have been weighing in as you've been presenting and showing things about how, not only how useful this is, but also how well explained it is. So, I would say this anyway, but don't just take my word for it. This is independent advice. Right, let me show my screen. So thank you, everyone. We're balancing, as you well know, the kind of a trade-off between wanting to show you loads of stuff and wanting to honor your time. So perhaps on this occasion we have balanced it incorrectly, but so many times you've said keep going. So it's kind of a tightrope we walk, but we really appreciate you staying along with so many people have stayed with this session. So thank you for staying for it. And also, just as a reminder, we've got some of the files that we've been talking about, we've been uploading in the background, so that if you go to that PDF, then you can see that bit.ly link. So the bit.ly then visualization project files. And this is what you find in there. You'll find a range of files that we've uploaded today, plus the files that have been uploaded on previous weeks. And we'll add this link to the YouTube description when we post the recording in a couple of hours' time. So if you can't get hold of the PDF or you're watching this recording, then just go to the description area and then you can see it. And just as a reminder of that, this is where you can find that YouTube tutorial. It is the Maxon training team at YouTube. Just search for that and then you can see not only this but all the other webinars that we've run over the last 12-13 months or so. So there's dozens and dozens of hours of content, something like 80 or 90 hours worth of things that we've recorded now, incredibly. So please also feel free to contact us if you'd like to reach out and ask any questions at training@maxon.net, or if there are any topics that you'd like to follow up. And as you can guess, we love making these project files. So if you want a little example, how do I do this? How do I do that? Just let us know. Training@maxon.net, that comes through to us. So fantastic. Thanks again. Anyone else want to round up with a comment before we depart?
Thank you, everyone. You're all great, and you're going to produce very cool car animations from now on.
Expect to see a lot of sequels to Fast and Furious from now on using this very technique.
Yeah, just give it a try. Well, we can make a little challenge and ask our audience to create car animations and just post them in social media and tag us.
Yes, please.
So we can see them.
Love that.
That would be cool.
Yes, absolutely.
Just a comment. I think in version 2 they're going to add the Greek button where the car parks anywhere and doesn't stop at red lights. I think that's works now.
That's just
and
your
it's warning all of the time.
Excellent. Well, thank you so much, everyone, and thanks everyone for attending. And thanks again. I know I say it every week, but I really do thank you for these lovely comments that you throw in at the end. That's it really makes this worthwhile for us. And also, if you've got any suggestions, there's a little survey that comes up when the webinar ends. So please throw in comments or suggestions for that too, because we read everything that you send us. Cool. So have a great rest of your day. And we'll see you next week. Next month, we begin FUI, Fantasy User Interfaces, and we'll be spending many hours on that and looking at different things, different ways you can build those quickly, both in Cinema and in the Trapcode and other Red Giant tools.
And John Lepore.
Yes, and John Lepore from Perception is going to be chatting to us about visual creativity, about exactly that. And he's done so many good things.
So excited.
Definitely check it out. He's great.
Cool. Take it easy, everyone. See you on the next one.
Cool. Bye, everybody.